beautiful people, and welcome. This is your practice test or your review for Unit 1 in Integrated Math 2. As always, if I make a mistake, please let me know so that way I may learn from my mistake, and that way you may learn from my mistake as well. This is not all of the review. This is just for skills 1, 2, 3, and 4, and then we'll be able to do a separate video for the remainder skills, which is adding, subtracting, multiplying polynomials. All right, let's go ahead and jump right in. It says use the graph at the right to answer the following. So find the domain. So let's recall what domain is. Domain are our x values. Those are our inputs. And those are our independent variables. So when it's asking you to find the domain, it's asking you what are all of the possible x values. I also like to think of domain is what are the possible x values, what are the not possible x values, what can x not be. So I'm looking at my x-axis here. I'll highlight the x-axis for us. Here's the x-axis. I'm looking at the x-axis. I'm noticing that there are things here, and I'm just sketching it out. I'm noticing that it keeps growing to the left, and then it keeps increasing to the right as well. So my x values are increasing to the right, increasing to the left, and something that was cut off here on this picture, and that's an arrow. So that just means it's going to continue to increase all the way to the right and all the way to the left. So if you look at the numbers, -2, -4, that means we are decreasing. We're making these numbers more and more negative. And here we are making these numbers from 0 to 2 to 4. We're growing these numbers. And so is there an end? Well, if the graph increases to the left and to the right, and there's no end to that, that means that all real numbers are in our domain. So you can do it two different ways. I like to use this type of notation, and I'm going to say it goes all the way from infinity to positive infinity. So from negative infinity to positive infinity. Now I know in my class we talked about the 3 different ways to show range and domain. This is just one of them. Any of those 3 ways will be fine. Now range is talking about the y-axis. So what do we say for range? Range is our y variables. Well, let's not call them variables. Let's say value, y values. They are our outputs, and they are our dependent variables. So let's think if we had an equation, the y, the answer depends on what we put in for x. So y is dependent. Now for our y, here, let's go ahead and do that. We're going to do exactly the same thing with our little sketches. So it cannot be -4. Do you see how there's a minimum value? So the smallest it can be is this value here. It doesn't go below, but it does go all the way up, all the way to infinity. These numbers are increasing all the way up to infinity, and these arrows show you that there is no end to them increasing. Now for the smallest number, let's figure out what that is. If I have -2 here and I have -4 here, and it stops right in the middle, that means I have a -2.5 or 2.5. You don't have to use decimals, you can use fractions. So when it's asking you what is our range, let's change colors here so it stands out a bit more. Our range is all the way from -2.5. Now I'm using brackets because I can be -2.5. It's not like it's omitted. I can be -2.5. And then I'm going to draw a comma, and it goes all the way up to infinity and beyond. Now we cannot grab infinity. Infinity is a concept. It's the idea of a largest number. So we're going to put a parenthesis around it because we cannot actually grab infinity. Let's state the end behavior. So when you're writing end behavior, you're always going to start out the same way. As x approaches infinity, y approaches something. And as x approaches negative infinity, y approaches something. So when we're talking about end behavior, we're talking about, hey, as our x's get super duper big, what happens to our y values? Well, our y values as our x gets super big, our y values go down from, I guess from here is what, 1.5, go all the way down to negative 5, 2.5, and then go all the way up. So we can say a few different things of what happens when we have a end behavior to the positive infinity. So as x gets super duper big, y has a minimum value, goes all the way up to infinity. So y approaches infinity. Because again, we're going to get super duper duper close to infinity. Now as x approaches negative infinity, so as we get here, we get super duper small. Again, what's happening to our y values? It does have a minimum, but it keeps growing all the way up, 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 and down, and it approaches negative infinity. That's our end behavior. List the maximum and the min. Well, the maximum, we said, it goes all the way up to infinity. So the max is infinity, positive infinity. And what's the minimum value? Well, the minimum value is this value that we already said, which is negative 2.5. So y is equal to negative 2.5 as our min value, our smallest value. List any intervals where the function is decreasing. Okay, so interval division. Decreasing, think of it as going downhill. As long as I'm going downhill, I am decreasing. So we are decreasing from infinity all the way down, all the way down to a negative 2.5. Now, typically we would switch that around. We can say it decreases negative 2. Well, let's keep it like that. And then where are the zeros of the function? So zeros of the function are the x-intercepts. So where they cross the x-axis. So here they are. Here's one, and here's another one. So here we have each one is 1, 2, 3, 4. That means this is 1. So there's 1 0 at x equals negative 0.5. And there's another 0 at x equals 2.5. Moving on to question number 2, write a description of the transformations needed to change the absolute value of x into the following. So we're looking at transformations. So here's 1. Keep shifting the paper, I apologize. Here's a 5. Now, negative is separated from 5. Here's my plus 2, and here's my 3. So negative outside of the function means we have a reflection. Let me write this in a marker here so you guys can see it. It's a reflection across x-axis. 5 is a vertical stretch by 5. 2 here, if it's inside the function, if it's inside the bubble, we're doing the opposite. So even though we see plus 2, it is shifting left 2. And then minus 3 is outside of the function, so we're going down 3. So if we have a parent function, so it's asking us to graph number 2. I'm going to skip number 3. I'm going to skip B just so we have some more space. So if it's asking us to graph this function, we have the transformation. We know what the vertex is. So the vertex is our h comma k. And now what is h comma k? H is the number you see in here, but the opposite of that. So in this case, h would be negative 2. And k is what we see here on the outside. In this case, it would be negative 3. So our vertex is negative 2, comma negative 3. Once you get your vertex, we're going to do a t-chart. So here's your x, here's your y. You're going to put your vertex in the middle. From there, you're going to go up 1 and down 1 as your inputs, as your x values. So for example, I'm going to try negative 1, and I'm going to try negative 3. So here what I'm doing, and I'm going to do this in my head, but I'm going to show you one time, is I'm taking my function and I'm plugging in this value, for example, -1, and I'm going to solve to get my output. So that's my input is -1, my output's going to be whatever you solve for. So -5 times -1 plus 2, that is +1. The absolute value, so let's wait on this second. The absolute value of 1 is 1. We still have that multiplication. Make sure you multiply before you subtract. This is -5 minus 3, 5, 6, 7, 8. You have a -8. Let's do that one more time with -3. -3 plus 1 is -1. -1 with the absolute value is +1. +1 times -5 is -5. -5 minus 3 is 5, 6, 7, -8 as well. So let's go ahead and graph this one here. So I have -1 and -8, which is all the way down here. I have -2 and -3, 1, 2, 3, which is here. And I have a -3 and a -8, which is here. Should have 3 points. Using a ruler or a straight edge, we're going to connect these and make these super duper straight, and it's going to look like an upside down V. Now, how do we know that it's going to look like an upside down V? Is because we had this negative out in front. Whenever we have a negative, that means it's been flipped. So our original function has been flipped to look upside down. All right, let's go ahead and move on. Ooh. We might have to do this on a separate sheet of paper. We'll do this on a separate sheet of paper. It says solve algebraically. So here's one of the questions. So this is 4A. So we are solving these absolute values equations. Step number 1 is you want to isolate your absolute value. So our absolute value here is x minus 3. That means I have two things I need to remove. I need to remove this +7, and I need to remove this times 2. Now, mathematicians are lazy. You don't see an actual multiplication there, but it is there. It's 2 times the absolute value. So I'm going to do a dotted line. First, get rid of the addition subtraction. So I'm going to -7, -7. So I think this is 8, 9, 10, 11, 12, 13, 14, 15. That is 8 positive. These two go away. Now I have 2 times the absolute value of x minus 3. I'm going to divide by 2, divide by 2. So I have the absolute value of x minus 3 equal to a +4. Now once you isolate, you need to do your first check. If this number is negative, so if equals a negative number, the answer is no solution. And we're talking about this number. In this case, our answer is positive. You can continue. So now let's continue. So how do we continue? When you continue, you're going to take this equation, this entire thing. You're going to basically copy and paste it twice. However, you are removing the absolute value symbols. So I have x minus 3 without the absolute value, x minus 3 without the absolute value. Now, instead of copying both into 4s, you're going to make one positive, make one negative. Now we're going to continue to solve for x. So I have +3, +3. So I have x is potentially equal to 4, 5, 6, 7. This one here is +3, +3. So x is potentially equal to -1. Now we don't know if it's actually one or the other. It could be neither. It could be, well, it can't be neither because we already have no solution eliminated. So it's either both or just one. So let's go ahead and do our check. When you do your check, you do your original question. Your original equation. So we do 2 times x minus 3 in the absolute value plus 7 is equal to 15. And now you're basically doing the same thing, except you're just plugging in your number. So I have 2 times the absolute value of 7 minus 3, absolute value plus 7. And I have 2 times the absolute value of -1 minus 3 plus 7. And we want to check if it's actually going to equal to 15. If it is, therefore, our answers are valid. If it is not equal to 15, then we do not have that solution. It is called an extraneous solution. So 7 minus 3, that is 5, 6, 7, it is 4. The absolute value of 4 is 4. 4 times 2, let's shift this up a little slightly. 4 times 2 is 8. 8 plus 7, so I know 7 plus 7 is 14, but we have one more, so this does in fact equal 15. So we are happy, 7 is one of our solutions. Let's check this one here, 2 times negative 3 minus 1 is a negative 4. Evaluate the absolute value first, so we have a positive 4. Oops. Once we evaluate it, we don't need the absolute value symbols. So now we have 2 times 4, this is a scribble, which is 8 plus 7, which is exactly what we got here. So that means we have 15. So that means both our answers for our equation, 7 and negative 1. Now, how do you write your answer? I am okay if you just put a box around these and call it good. If you really want to do it, you can do like a set notation. You can do like squiggly line, negative 1, comma, 7, squiggly line. You can do that, or you can say x is equal to negative 1, comma, 7, or you can just say x is equal to 7, x is equal to negative 1, and put a box around it. Either way, it's all giving you the right answer. All right, beautiful people. That is it for your review. I hope you enjoyed this video, and in the next one, we'll be dealing with modules 4 and 5. Thank you so much for watching. Bye.